Hi guys, this is a question from chapter 7. The question says, a Genesis drill starts from rest after 2.9 seconds of a constant angular acceleration and it turns at a rate of 2.5 times to the fourth rev per minute. A says, find the drill's angular acceleration. So we know that the angular acceleration is equal to the angular velocity divided by the time. We have the angular velocity, but we have to convert rev per minute to radians per second. So right now I'm gonna be writing that out, and now I'm gonna show you how to do it. So we're gonna take our given, which is 2.5 times to the fourth. Then we're gonna do rev over minute. We're gonna times it by 2 pi over 1 rev, because that's the conversion. Because 1 rev equals 2 pi over 1 minute divided by 60 seconds. Then all the units will cancel out. Minutes will cancel out, revs will cancel out, and what you're gonna be left with is radians and seconds. And I believe the answer is going to be 2146.8 radians per second. But we're not done yet. We didn't find the answer. So now we're going to take this thing that we converted and plug it back into our equation. So we know the angular acceleration is equal to W over T. So we found what W is. It's 2146.8 divided by 290. Okay? And that will give us 740.3 radians per second squared. Okay, that's the angular acceleration for this problem. Okay, and then we checked, and then it was the correct answer. B says, determine the angle in radians through which the drill rotates during this period. So, because we have acceleration, and then we have the angular velocity and time, we could use one of the kinematic equations pertaining to angular rotation. So what I'm doing right now is I'm going to be pulling up the kinematic equations that we could choose from. This is for linear distance, but we could change it to angular distance. It's the same equations, but different letters that mean different things in different forms of motion. So what we're going to choose is we're going to choose W squared equals W initial plus 2 times the angular velocity times the angular distance. So right now I'm going to be writing that. Sorry, it's taking so long. Yeah. WF squared equals the initial squared plus 2 times the angular velocity times the angular distance. And now we're just going to plug in all our givens. We found out what was the angular final velocity, which was 2146.8 squared equals 0 squared plus 2 times the angular velocity, with angular acceleration that we just found, which is 740.3, times the unknown that we don't know. And you just solve it like an algebraic equation. Okay, you just do 2 times 740.3 . Okay, we got that number for the left side. We got 1480.6. We're going to divide that from both sides. Okay, we're going to divide that by both sides, and we get an answer of 3,112.8 radians per second. Radians, I mean. Okay, and then you check it back up to the initial answer, and I noticed that it was correct. So, thank you for watching my video on how to explain this problem, and see you later, guys.